Hello, everyone. On behalf of CyberMindr, I'm delighted to welcome you to today's webinar, which is on securing the cloud software supply chain, strategies, and best practices. A quick introduction to CyberMindr. CyberMindr is an automated and continuous attack path and threat exposure discovery platform. Our proactive approach helps organizations continuously monitor and manage their external attack surface, significantly reducing exposure to potential cyber threats. Now, moving on to today's session, we are thrilled to have Anjali Shukla with us. She will be sharing her expertise on securing the cloud software supply chain. Anjali is a seasoned cloud security engineer with over 6 years of experience in DevSecOps, Kubernetes security, and cloud platforms like AWS and GCP. She is the founder of Kubernetes Village, a community dedicated to Kubernetes security, and leads the OAP's EKS GOAT project focused on AWS EK security. An active contributor to the cybersecurity community, Anjali has volunteered at events like Cloud Village at DEF CON, Besides, and more. She is also a recognized AWS community builder and has spoken at renowned conferences including Black Hat USA and Europe, NALCON, Seasides Goa, Besides Bangalore, CSA Bangalore, and KubeCon. Throughout the session, if you have any questions, please feel free to drop them in the Q&A box. We will address them towards the end of the discussion. With that, I will hand over it to Anjali now. Over to you.
Thank you, Nazia. So, hello everyone. And today our topic is really interesting one, the software supply chain in cloud. So, this is an attack surfaces which is present in silent, but it is growing very fast. So, I thought of discussing on this topic further because we have so many kinds of a supply chains attacks and how to mitigate that. What are the common attack surfaces when it comes to cloud? So today I'll be focusing my areas with respect to the cloud. And thank you, Nadia, for my introductions. So today's agenda is, first of all, what is software supply chain? And then what it means by in a cloud. Then we'll talk about the recognizing common threat. So here I have case studies or you can say the recent attacks that has occurred in the past. And then we'll talk about the best practices and the security and the strategies that we can do to protect our environment. So I am Anjali Shukla, Senior Security Engineer. I won't be going on my introduction in detail because Nadia has already given my introduction. So yeah, I am a founder of a Kubernetes Village and leading OWASP EKS Goat project. I am a trainer and speaker at Black Hat, Seasides, Nalcon, Cocoon, and various international conferences. So let's start with today's topic and the first slide, which is what is software supply chain. So in a traditional way, like if I talk about any manufacturing company or any traditional supply chain, so this term supply chain is derived from a traditional layer of or the steps or the processes that we perform when we have a raw material. We make something good out of it. Let's say we have a cloth, or we have a normal cotton fiber, and we produce a certain like nice t-shirt or a top out of it. So we produce something good out of from the raw materials, and then we package it and then deliver to the stores so that our users can use those produced good. So that is a supply chain in a traditional way, like from the raw material we are manufacturing or we are developing into a published or the available state. So this is the same in software supply chain as well. We have certain open source packages, source code, dependencies, and we build something out of it. It can be our any applications, a software, or anything we build from our sources and then dependencies. And then we apply certain security into it, like we apply the firewall rules, we apply the security groups, and then we deploy it onto a production environment. Now, when it comes to a deployment, it can be your application running on a virtual machines, or it can be a containerized application, or it can be an application running on a Kubernetes infrastructure, or you can have data centers as well. So it depends like how we are deploying that application. So that is a a basic cycle, or that is a basic supply chain with respect to a software. Like a software is built with respect to or with certain dependencies, certain packages, and then we build a architecture of it, or the security, like how the traffic will flow and how our application will deploy it, who all will be having access to that applications, and finally with that we deploy that applications to our infrastructure. When it comes to a cloud, each cloud provide certain inbuilt or certain in-house cloud native services that we can leverage. So in a normal software supply chain, we can use our version control system, our code repository where we'll actually keep our code. For the build system or for a CI/CD, we can use a Jenkins. For the automation, we have Ansible, Terraform. So we have multiple open source tools available for our normal supply chain. But here, as the topic is with respect to the cloud, so I have added the services that are offered by the different cloud providers. Like in code, first of all, we can take it as a GitHub only. So that is a normal GitHub that we have. And then we have a Cloud Shell. So Cloud Shell, earlier in AWS, we have a code commit where we used to keep our code. Now they have deprecated the code commit service and moved it to a Cloud Shell only. So we can keep our code onto the Cloud Shell. And similarly, in the GCP, Google Cloud Platform, we also have a Cloud Shell. Whereas in Azure infrastructure or in Azure DevOps, that is another service under the Azure umbrella, Azure DevOps. And there we have a Azure repos. So that is specifically to keep our code. It is similar to the GitHub. We can create a PR, we can keep our code, we can maintain the commits. So it's pretty much similar to the GitHub only. So we have Azure repos in in code stage. And then we have, if I talk about the IAC, then we have a Terraform and CloudFormation. Terraform is by the HashiCorp, anyone can use it. It is not cloud native, but CloudFormation is AWS specific. So if you want to use an IAC service in AWS, then you can use the CloudFormation. Second, if I talk about the second stage, then we have a build. So build is where we are actually building our applications. So or building our code. So we have a cloud build, code build, Azure pipelines, code pipelines, and the further CI/CD pipeline. So cloud build is a service in GCP which is specifically used to build your code. And similarly, we have a code build in AWS. Azure, in Azure, we don't have a specific service in Azure DevOps to build the code. We have Azure pipeline. So within that pipeline, we create a certain stages Azure pipeline, and there only we build our code. First of all we get the code from the repos and then we build it. If you would like to add certain security solutions like SCA scans or container scanning, that also you add everything into a Azure pipeline, and similarly you do it in a code pipeline which is a component of AWS as well. And then we have a traditional CI/CD pipeline, which is a Jenkins and Spinnaker and different pipelines we have that we can use. Third stage is artifact. So artifacts, once our code is built, we need to uh, save those things. Like if it's a Java application, we need to store the jar files into an artifact repository. Or let's say if I am deploying my infrastructure to a Kubernetes environment, then an image will get built. I'll build an image and keep it into a container registry. So first of all, we have an artifact registry. Artifact registry is a part of a GCP and it is a common service. Earlier, there were two different services like container registry and the artifact registry. Now GCP has merged these two and call it as an artifact registry. So if you would like to keep your Java file or any other artifacts, you'll keep it in the same. And even if you're creating an image, a container image, then also you'll keep it in the artifact registry in GCP. For AWS, we have ECR, Elastic Container Registry, similar to a Docker Hub. And then in Azure, we have a Azure Container Registry. Last part is a deployment or the publishing our application. So it can be on a virtual machine, which is compute, we call it a compute engine with respect to a GCP. And we have EKS, sorry. We have EKS, which is Elastic Kubernetes Service in AWS. Then we have a functions, Azure functions, Lambda, or different kind of functions. And then we have a EC2, which is nothing but a virtual machine. So I have added three things here, like a virtual machine, functions, and Kubernetes. There can be a ECS, which is a containerized applications as well, or there can be a data center as well. And then finally, it is served to our consumers. So now, quickly, this was the basic thing that I have covered. Now I would like to go to the little advanced one, which is a case study. So here I have added certain case studies, which is in which first is a package compromise like npm go and py. So npm, this was the recent compromise, and the go as well. And I think you have come across these kinds of an package, like uh, agenda of an attacker. It's saying they'll keep the malicious any npm go or py packages, and then people unknowingly download that using into their code, and they'll get compromised. So this is the same thing. It happened with the npm package as well. So while researching, and the researchers came to know that there is an unusual package that is detected by their pipeline, their malware analysis tool. And the package name was rand user agent. So it is an npm package, a Node.js package, which is used to generate a randomized user agent string, in a nutshell. And that package was initially designed for the web scraping. So what exactly happened in this case is that attacker committed three malicious version in an npm registry. So if you will go and check the GitHub repository for this particular rand user package, then there was no update since 7 months. So since 7 months, there was no update in this package. So attacker has taken advantage of it, and its latest version was, I think, 2.0.82, and with just minor difference in their versions, attacker published three malicious versions, and which was 2.083, 1.0110, and 2.084. So likewise, three packages they had the attackers published into an npm registry. So when researchers checked this unusual package, what they did is they first of all checked the GitHub repository, and they found that there was no updates in 7 months. But if when they checked the npm registry, there was three new packages. So what we have a tendency that whenever there is a latest release or latest release of any package is there, we tend to download the latest version, right? So likewise, many organizations used the latest releases, and approximately 40 to 45,000 organizations were impacted because of this malicious npm packages, because they used the latest version and they did not check or they did not validate with the GitHub. So what exactly was there in that package? So there was a obfuscated code. So obfuscated means you are making a readable code into an unrecognizable or ununderstandable piece of information. So you will be seeing like, okay, this is something, but I'm not able to understand it. It will not be the jargons for you. You will be able to read, like there will be a curly braces, some numbers, some information, but it will be in obfuscated form. Means you won't be able to understand that piece of information. So there was a long, approximately 20 to 25 lines of code that was added into that rand user agent package into these versions. So when researchers tried to um, retrieve that information from that obfuscated piece of code, they found that there was some informations like there was a backdoor that attacker has created, and there was two IPs that they found. One was to create a communication from the with the C2C server, which is an attacker control server, and the second IP they found to send all the files of the affected system to the attacker control system. And this was the really nice example of a rat. Rat is a remote access Trojan, and they use a feature which is a Windows specific path hijack. And why they use that? Because what the like in the backend they were running a Python script, and if you'll see like, okay, something is wrong with my system, and you'll go and check the log, and you'll find some Python file is running. You'll be like, okay, this is a Python. I must have used the some Python code. If you'll a developer, you might be using a Python on regular basis. you'll just say that, okay, some Python information is running. So that is a pretty good thing about this Trojan, that it will hide itself under the Python file and it will silently run into your system. And you won't be able to recognize that, okay, that is a backdoor which is actually sending all your files and informations to the attacker control server. And using this Python 3127 path hijack that they have used, the malicious package, you have the ability to run specific commands, like you can execute some shell commands and you use some commands to perform certain attacks. So that was the complete attack. They just added a malicious piece of code in that package in an affected versions and in the malicious packages, and unknowingly the users downloaded those packages, and in the back end, that Python script ran and started sending all the information of their credentials, files, and all to the attacker control server. This was the complete attack, and similarly happened with the Go as well. Go, they used the Linux server instead of a Windows. So next we have, like next case study we have on the GitHub Actions. I think you must be aware recently in an April or so, this was discovered in the TJ Actions slash changed file. So as a CI/CD, we generally use the GitHub Actions. We have the GitLab Actions, GitHub Actions. Some uses the Jenkins, some uses the Azure DevOps, or I've seen rarely people using the code pipelines. So this flaw was there in a GitHub Actions, and the attacker started with the compromised PAT token. PAT token is a personal access token that we generate to provide some piece of like, and that token has certain permissions. So this compromised PAT token has permissions of the, like this token was a TJ action bot. That is a kind of a, you can say, a package that we use to perform certain tasks. So they use this compromised PAT token, and this PAT token belongs to the TJ action bot, and that token was having write access to the repository. So if any token is having a write access and that got compromised, itself is a kind of an havoc, because that token has the write access, and any attacker can do certain changes in my repository. But that token belongs to a TJ action bot. So what the attacker did is they added the malicious code and they write that payload in such a way that it will extract the secrets from the CI/CD pipeline. Now, how this attack took place is, so I would like to switch to the next slide to explain this. So see, this is an example of a job. So we write a job and I'm providing the environment that I'll be using Ubuntu latest, and I'm providing certain actions checkout. This is a default one that you use checkout at the rate version 3. So here, if you will notice, I'm using tj-actions changed file at the rate version 35.7.7. So first of all, this specific action is used whenever I would like to check that if there is any file change in that PR or not. So sometimes we have a requirement like perform a X task only when there is being change in a Y file. So likewise, we can have a use cases. So that's where we use this TG action change file thing. So they leveraged this version. We like some for let's say for example that version was 35.7.7. So what they did is, now as a trusted user or as a trusted advisor, I know that if I'm using this version 35, I know my request is pointing to a valid or to a secure point. That is what I will think because I'm using this since so long. But that's where they tricked it. They changed this, they like the version, let's say it is pointing to a XYZ file. They changed that pointed file and there they added the malicious code to extract the credentials from the environment. So let's say I this version is pointing to a XYZ and I have changed it to a V1, like with whichever tag which looks the legitimate one. So I have changed that. Basically, I've changed the pointing method of that one. So now, whenever I will run it, and whenever that CI/CD pipeline will run, it will extract all the piece of information unknowingly because now it is pointing to a malicious version. So the attacker updated the multiple version tag just to make sure that their request, like they will get a credentials out of it. That's why they have make changes, or they have added that malicious code or their payload to extract the secrets into a multiple version. And then they pointed to a malicious command. And they make sure that the workflow at least take one version out of these three or four tags that they have compromised. And once the CI/CD pipeline runs, it performs. So basically, what will happen when the CI/CD pipeline will run? It will print the workflow logs. Let's say I have 5 stages in my job. I have a 5 jobs. So in the first job, I am saying that clone the code. Second job, I'm saying run the infrastructure as a code, or maybe just change in that ABC file. So likewise, I'll be having a 5 different jobs. And the third job, I'm connecting to a DB, and before that, I'm fetching the credentials. So it will print all the logs. So this use case or this attack was possible when there was a workflow log publicly accessible. But earlier the credentials was not dumping. When they changed or they pointed to a malicious commit, the CI/CD pipeline started dumping the credentials as well. But the credentials was in the double base 64 encoded, but still you can decode it. So that's how the complete flow works. So the attackers, first of all, they got the access of the PAT token with write access, and that token belongs to a TG action bot. Now the attackers created a malicious different version of a tag so that a legitimate job can point to a malicious code or a malicious commit. So once the CI/CD pipeline starts running, it will dump all the secrets or all the credentials or the customer's data present in that environment, in that runner environment. And you can see all that information in a log, workflow log that is printing or that is coming. So if you have used the GitHub Actions, when your pipeline is running, it is giving you all the information. It is similar to the Jenkins. When you run a Jenkins pipeline and when your jobs are executing, it starts printing, like it starts to print logs in a console output if you have used the Jenkins before. So similarly in the GitHub Actions also, you can have the workflow logs. So there only you will have all the credentials information. Third thing, we have the case study related to the Terraform plan. So the Terraform plan, or the Terraform we generally use, it is a infrastructure as a code, and we use it whenever we want to deploy our code, or whenever we would like to create infrastructure on cloud. So we have a certain methods to, let's say I would like to create 50 VMs on a cloud. So one method is I can use a console. Second, I can use a CLI. I can use the SDKs to perform my task. And then I can use a Terraform to automate that. I'll write one piece of code and then I'll just provide the number and that's it. So that's the fourth option is a Terraform. So when we have a very big infrastructure, we cannot track all the resources either by console or by Boto3 or I mean or by SDKs or by CLI. We need, let's say I have 100 users working in the same team. I have to keep a track like how many resources are created or how many resources are present on my cloud environment. So that's where Terraform comes into the picture. So Terraform gives you the ability that you can create the infrastructure and alongside you can keep a track of it. How? By maintaining a state file. And if you will make any changes in your Terraform code file, it will track that as well. First of all, it will refer it. So this referral, let's say I already have 2 VM deployed in a US East 1 region on cloud. And now I am changing or I'm adding a security group in one of that VM within the same region. So when I will write a new piece of code with adding the security group to my existing VM, Terraform will check it with this state file. It will check it that whether this VM already present in this US East 1 region or not. If it is already present, it will just attach that security group or new code to my infrastructure. That's it. So how it is doing it? It is tracking with its state file. So in Terraform, we have three main important steps, or we call it a lifecycle. init, Terraform init, Terraform plan, and Terraform applier. Difference between these three is init, we run first of all to initialize all the modules. Let's say in my Terraform code or in a Terraform file, I am writing I will be using the virtual machines or an EC2 instances and a security group. So how Terraform will come to know? It will read those modules, virtual machine, EC2, compute engine, or security group, and then it will import those modules from the Terraform registry. So by default, it uses the Terraform registry to import all the modules. So in the Terraform init step, we are initializing all the modules that are present in my code. Second is a Terraform plan. So plan, as the name suggests, it will just give you a blueprint that these are the resources that are going to create on your cloud environment. It will not actually create it, it will just give you the plans. That's it. And when it runs a plan and whatever code you have written with respect to that, it will let you know that there will be two changes or two new resources will be created. One will be destroyed or two will be destroyed. Likewise, or one will be updated. Likewise, it will give you a piece of information. So we run a Terraform plan when I have to review my changes that, okay, what new is going to create with the existing infrastructure. I compare it with my plan because I'm not actually creating, I'm just getting a blueprint or a roadmap for it. Third is Terraform apply. Apply is the stage when you actually deploy all the resources onto a cloud platform. So why I'm explaining these three? Because that's where this RCE comes with Terraform init and a Terraform plan. So now I have, let's say I have a very big infrastructure and there is a central repository that I am keeping for my view. And there are 50 developers or 50 SRE team or the DevOps guy working in the same team on a same repository. Now there can be chances. I mean, I have an existing infrastructure, and let's say new user come, I have to add it with the Terraform, or new project come, I have to add it with the Terraform. So there is a new change. So I, as a DevOps user, I will go write a code only for creation of a user and will raise a PR. That PR will get reviewed by the admins or by senior DevOps, and then they will merge this PR into the main branch, right? So before getting merged, like before they merge this PR into a main branch, what do we have in the backend? We have a Terraform init and a plan running. Because how we will compare these two changes? If I have a 200 piece of lines, I cannot just directly compare it. I need some piece of information to compare it. So for the comparison, what do we use? So for comparison, what do we do? Like whenever there is a new PR is generated, PR is a pull request that we use in a GitHub. So whenever there is a new PR is created, CI/CD pipeline, the GitHub action will run automatically in the backend and it will run two commands. Terraform init to import all the packages and Terraform plan to give me a picture like what is going to create and what is going to destroy and what is going to update. So that is a default nature, a default use case that we have in almost every organization. So now if the PR is there, I have all the lines changes around the lines added, and then I have a plan, Terraform plan. So now I will make the comparison with my existing infrastructure. I'll review it and I'll merge it. So this RC lies here in the Terraform plan. So if you want to test it or if to test how this exploit work, what you have to do, you have to create a CI/CD. You can take a GitHub action for a simple use case. And as an attacker or as a researcher, what they did is they created a custom provider. How the custom provider looks like? Something, no, this is how you import it. But yeah, they have created a custom provider, and that will what that custom provider will do, it will exfiltrate the credentials. How it will exfiltrate the credentials? If you're deploying your infrastructure on the cloud, means you might be using a secret manager, DB credentials, some parameters that you have stored. So these kinds of credentials you generally use, right? um, if you're running a Terraform, you need an IAM permissions. You need those credentials as well to run that Terraform code or to deploy those resources. So all these piece of information, you can you can exfiltrate that with the help of that malicious code. It depends what you are actually writing in that provider. Are you writing a command for the secret manager and getting the secrets out of it, or what you're doing? So attacker have written a custom provider with the malicious code to exfiltrate the credentials, and they pushed it to a Terraform registry. Anyone can push their custom provider to a Terraform registry. And now, as an attacker, you have to use the same provider in your created branch or in your IAC branch. And then you will just open a PR for that to review. Now, what will happen if you have raised the PR with the malicious code or with the malicious provider? When your CI/CD pipeline start running, it will do another Terraform init, and in the Terraform init stage, it will download that custom provider, and in the next step, which is the Terraform plan, it will execute that provider, right? So in the logs or in the output, you will be having your credentials as well. So it depends on you how you have written the custom provider and how you are taking or how you are leveraging it. So that's how this RCE work. And I have added references to each and every slide so that in case you would like to have a more research on it, you can go through it. Another So when the researchers started exploiting or started looking into this Terraform RC, they found the additional modules like externals, logs, and different things that you can play with this RC. Now, so like this, I've just added a snippet how you will call that module. So in the request, sometimes we define like what are other required providers. So in that, we can just call that our evil modules with the malicious code. So next is the best practices and the strategies. So first we discussed about the NPM packages. So if it is a build or a that kind of an attack surfaces, you can check that from where that package information is coming. A very good practice to track all that information is having a list of SBOM. SBOM is software bill of material. So, like we have an ingredients at the back of every edible products, like let's say a chocolate, like what are the ingredients used to make that chocolate? Similarly, we have an SBOM for our software. So, what are the open source or what are the packages we are using in our code? So it has informations like name of that package, um, latest release, affected version, who created that package, and the date of that. All the informations we have in the SBOMs. We have a tools like Swift Grip with which we can generate an SBOM from our package.json or any like for our packages. We have open source tools available. So likewise, we can keep a track of it, and in case there is some vulnerable or the affected versions comes in the future, we already have that list handy with us that, okay, we have a 30 applications running and here are our 30 SBOMs. We know that on for all the 30 applications, how many of them are using this affected version or that affected packages, and what is their existing package version. So likewise, it is easier to remediate that faster. Next, we can use the commit hashes. So this practices I added specifically for GitHub action thing. So here, if you'll notice, I'm using a tag version here. So instead of tag version, you can use a hash of that commit so that even if there is any change, that if there is any change, SHA will also get changed, right? And you're using the or restricted or maybe non-malicious SHA, so your application will be safe because version can be point to a malicious one, but if there is a SHA we are using, and if there is any change in that pointed file, SHA will also get changed. So maximum like you can have is an error that okay your pipeline failed because it is SHA does not like SHA mismatch or something like that. So instead of using a version, you can use a SHA of the commit ID or like test. So that is actually a good practice instead of using a tag, and it is valid with respect to the images, like container images tags as well. We use a version latest or we use a specific versions. And generally, I've seen people using a latest version just to have the latest image. It may be the base image or it can be the POC image. But even if that a POC image and you're using a latest version, there are chances that your environment get infected because that image is present in an connected environment. It can be a part of a dev cluster or a staging cluster, and you are using a sharing VPC or like some certain shared resources. Next, we can monitor our all the distribution platforms, and we can monitoring and auditing really helpful whenever there is an attack or you would like to backtrack like what went wrong. And regularly we can notice that okay, if we are using any unauthorized if there is any unauthorized change or any unauthorized user uploaded some kind of an image or something like that. And even we can restrict the access control as well, uh, especially the access control of ECR repository or the artifact registries who have the permissions to change like tags, because tags are mutable in nature but the SHA is not. So likewise, we can, with the help of access control and the restrictive methods, we can monitor that. And then for the Terraform RC use case, we can use the plugin directory. So like I mentioned earlier, in the Terraform init, by default, the Terraform pulls all the plugins from a common registry, which is a Terraform registry. But if you will specifically mention, so let's say you created a list, as a security engineer, you created a list of certain plugins that these are the legitimate one. You checked it, you validated it, and you created a list and you downloaded all those plugins and created a directory. Now, whenever there is a Terraform plan or there is a Terraform apply is being used, you are fetching or you are downloading the plugins only from the specified directories, not from the Terraform registry, which is a public in nature, but your maintained security team maintained the Terraform plugin directory. So that also you can use that. Another remediations, this we have. So yeah, so for this we have discussed that we can maintain a SBOM list and we can see okay which is the malicious and which is the cleaner package here. And whenever we are updating our applications, because we have a CI/CD pipeline running in the backend, and we generally have a tendency that whenever there is a new release of code or new release of version, it will automatically run and deploy it onto the production. So what we can do, we can here also we can do an SCA scanning as well, which is a software composition analysis, and it will give you the information about the packages. And there also you can put a threshold, like if you have any critical uh, packages, or let's say you have a three critical or you have a one critical, then the pipeline should stop then and there only. It should not get deployed. Or you can say that if you have a four high or a three medium like that, you can just put a threshold limit there. Then the pipeline should stop working. This functionality is provided by open source and commercial paid solutions as well. It's up to you, whichever you would like to use. So for the GitHub, we can use though GitHub has already fixed it just after this, this was discovered. But yeah, from your side also, you can restrict the pad tokens permissions and you can use the SHA or the commit ID instead of the directly using the version tags. And then for Terraform plan, we can provide a list of certain plugin directories that we can use. Um, yeah. I think, yeah, that's it from my side. And so, like I mentioned, that I am leading the OWASP EKS Goat project. So, this is the EKS security.kubernetes village. This is open source. This is the documentation present at this link, and you just need a GitHub account and AWS account to deploy the labs. And in a hands-on way and in fun and hands-on way, you can learn about the Elastic Kubernetes security. And it has the attack and the defense and the basics as well. So yeah, that's it from my side. If you have any questions, please feel free to ask.
Thank you, Anjali. There are a few questions. I'll take it up and help you. Okay, so there is one question. What are the most common threats currently targeting the cloud's supply chain?
Okay, so what are the most current threat is the main one that I have discussed is the build stage, that is the package related. Because if we generally have a tendency that if I am using my, like I'm writing a code as a developer, I'm writing a code, I will just, if I need, let's say XYZ package, I will just use that package, like whichever compatible with my application. I will rarely see that as a developer, I will rarely see that, okay, which is the affected version. If there is any vulnerability discovered in this package so far, what is the affected version, what is the stable version, that is we rarely check. And plus, in a supply chain, there is a framework called SLSA, I think. There is a list of like AB in terms of an ABC. Like when we are building a packages, we have to make sure that we are using the legitimate packages. There is an there is an attack surfaces after each of these steps. That also you can refer for the most commonly. So we have a so in that most commonly is the package related package compromise that we call it. And the second one is the CI/CD compromise. So how the CI/CD gets compromised is that we generally have a CI/CD tool, and their access control is missing. That is, I've seen in the most of the cases, like the access control onto that CI/CD solution that we're using. I have seen many a times that the organizations are using Jenkins with the admin and password, and it is publicly hosted Jenkins. So you'll just go. You may not be having a permission to write to make changes in those pipeline, but you will be having a permission to see the console output, to get the console logs. And if you're getting the logs like the GitHub Actions as well, then you will surely get a really nice piece of information here. So that is also one thing that you can take care of in the supply chain.
Okay, the next question is how long it will take for troubleshooting?
Um, Troubleshooting what?
Krish Gupta, can you please specify that question?
Yeah,
Okay,
can you
meanwhile, I'll just take up the next question. Uh, where do most companies go wrong when securing their cloud supply chain?
most companies go wrong is they take the security as an aftermath, and companies generally focuses on the business and the organizations building the infrastructure. And with respect to the security, what they generally do is they get a, if there is a web application or if there is a mobile application, they get the pen testing done just to clear the audits, and that's it, I think. But in a supply chain, there are many things that companies are missing, not creating a list of SBOM, not creating a list from where our application using open source packages, and we have largely seen we had the log4j example, the npm package, pypy, there was a numpy package. There was just so many package related thing that, because see, in an application there are chances that you might be using approximately, if it's a big application, 200, 300 packages. And even after, like if the SCA scan is done, which is the software composition analysis, the scan is done, that is the one thing. Not fixing it, another thing. So we have seen in an organization, like we are getting the SCA scans report, but we are not fixing it. We are taking it lightly. Okay, we have this report, we'll take it into a next sprint and next quarter maybe, and that's it. And then one package compromise comes, and then there is a panic in the organization, like okay, we are also using this, how we will remediate it. So the remediation thing, we are not in the supply chain, we are not remediating at all, because it's a package related. I understand that it require a lot of challenges, a lot of efforts you want, because you will be deploying it application with the new or with the legitimate package and updated package, and then you have to retest it and deploy it. But yes, if you want a security, you have to do it. And then in the supply chain, there is a parameter security also that you can do. So uh, we are we are allowing the traffic, that's okay, but we can have a parameter security as well. That even if someone um, allows the traffic in the deployment state and made that thing public, it should not go public, because there is another parameter security that we have in GCP specifically, that is a VPC service service control. So you won't be able, even you have a permission, you won't be able to make that bucket public if you will not whitelist that path under the VPCFC. So that is a parameter security. That is also where the organization is lacking. And thirdly, the organizations in with respect to the cloud, the supply chain, they are relying most of the time they're relying on the tool, but rather than the tool approach, the manual auditing, I won't say, but the manual approach and taking the looking at the infrastructure, doing the threat modeling, and see like what are the basically the manual intervention, manual effort should be there to validate those risks and see what can go wrong, just not relying on the solutions.
Actually, the next question is which one is the vulnerable component in OAP's top 10?
Which one the vulnerable component? OS top 10 is all about the vulnerability. So, all I mean, those are the whether it is an XSS, XSC, SQL injections, TMLI, broken access, lack of monitoring, everything is vulnerable. So that is why we have the OWASP time. Can you maybe if you can elaborate your question, it will be easier for me.
Okay, and someone is asking, can you cite recent real-world example of cloud supply chain compromises? What were the key
Yes.
lessons?
So, in case of a solar winds and the Log4 shell, is the Log4 shell was a different case because there was an like there was a package vulnerability, and then through that you will make a connection to the port, and then you will get access to the reverse shell. Solar wind case was, I think they have, if I'm not wrong, they have started with some compromising the token. They got the access of the token, and with that token, they were able to get the credential. I think the Orion tool, the SolarWinds Orion tool, that was got compromised, and they got access to their customer data, their other in product details and everything. That was because of their token was leaked. So Solar in that SolarWinds and even the GitHub Actions, these cases their tag token, some token was compromised. So that was the initial level, like the entry gate for the attacker. In case of a package vulnerability, it's mostly the case where the malicious code or the attacker pushed the malicious code into a repository and unknowingly we are downloading and reusing it. And that was similar to the Log4 shell. There was an example of a NumPy, I think, if I remember the name correctly. So that was the case where the um, because the like author of those packages, they have stopped the development of that packages, and they have even removed the bucket, the AWS S3 bucket as well. There was a bucket takeover at that time. If like if you know how the S3 bucket takeover, you just have to create the attacker basically check that the domain it is pointing to an S3 bucket, and that S3 bucket doesn't exist. So he claimed that S3 bucket, and the attacker uh, the attacker stored its malicious piece of with the same version of NumPy into the AWS S3 bucket, and people unknowingly downloaded those malicious versions. So likewise, these package compromises work.
There is one more question. Mostly companies get compromised due to outdated components. So, is there any way to monitor components version and real-time update in case of any impacted CVEs of the specific version that's being used in the environment?
Right. So outdated, when it comes to outdated, there are multiple things like you have an outdated piece of software that you have that is generally maintained by the IT team. They generally send you an update. Like in a big organization, we don't have an entire control of our system. The IT team controls it, and you generally don't have the admin permissions as well. So they generally they send you an update that there is an update. Please update it because of it can be a browser update, it can be a system update, depending on that. So that is a software update. In case of a software supply chain components and package related, SBOM is the one that you can create it. And plus, if you're doing an SCA scanning, that also you have the package list, or like SCA for a normal software or for the container images, you have that, okay, this is a vulnerable version. You update it to, let's say, 2.3, or you update it to 2.4. So likewise, you can maintain it. And sometimes the CSPM solutions also, whether it is an open source or like they also give you an information that this is a VM, and It is running the open SSH, like port 22 is open, and it is running that vulnerable package, open SSH package, and that also you can do it.
Okay, if you can just take it up this one. What is the best method to store tokens?
Secret managers, any password manager solutions you can use to store your token. It can be um, so there are multiple, like we have the Bitnami Secret, Vault, HashiCorp Vault. If you're using a cloud, then we have a secret manager by AWS. We have like by AWS, Azure, and GCP all provided the secret manager. So that is the best way that you can use it. And if you're using a, so there is a difference between secrets and a parameters. If you're using a parameters like it can be a DB port or it can be a private IP, then you can use it a parameter store and you can mask that value or obfuscate that value. That also you can do it.
Okay, and someone is asking if I am executing EPC or EPCM project and stuck up with your software because of validation, then how long it will take to validate?
Okay. Can you elaborate like what is EPC?
Krish Gupta, would you like to take up this question and ask the speaker directly? I can unmute you. You can just raise your hand and I can unmute you. Okay, meanwhile, I'll just take up the last question. Uh, okay, how do you prioritize risk in a complex multi-cloud or hybrid environment?
Okay, so risk we prioritize based on the impact it is making on the business and the on the infrastructure. So all the public facing asset, if there is any, like bucket is getting public, like bucket is present in a public environment or database, any VM with the 22 port and the password and the username enumeration, like password and the username brute forcing is there. So these kinds of public assets we have, like Vertex AI we can have, App Engine we can have, these kinds of cloud services, we take it as a critical because it has a more risk. It is present in a public environment. Then there are two kinds of a public thing. First, publicly accessible, and second is accessible only to the VPN. So VPN is a kind of a less priority because okay, it is accessible only to the VPN, but if it is publicly accessible, we take it as a critical. Second, next, how it is making the impact on the like because see, whenever as a security engineer, if I'll go and say, okay, these are the critical and these are the three high, and let's say two critical you have and you have to fix it, you have to remediate it. The first question they'll ask, what is the impact? How it can be exploited? So you have to tell them that, okay, what are the possible ways it can impact to the business directly? If it is cost efficient, let's say the IM role is present and the users have access to create to spin up a VMs or to spin up a database, that it has a cost factor. So likewise, we prioritize the risk and on.
Okay, thank you so much, Anjali, for your time and for delivering such an insightful session. We truly appreciate your valuable contribution. And to everyone who joined us today, thank you for taking the time out and joining us. We hope you found the session informative and engaging. To stay connected with us and explore more resources, please visit our website, cyberminder.com. Also, don't forget to follow CyberMindr on LinkedIn for daily insights, updates, and knowledge sharing content. Thank you once again, and we look forward to seeing you at our next session. Thank you.
Thank you, everyone.